I am Kumar Dasarathi, Dalai, Assistant Professor in Electrical Engineering Department. So now I am going to discuss about electrical machine, which is a subject. So from that subject, I am going to discuss one topic, that is transformer. Okay, see. So transformer. So you might have heard about this transformer, or so often we are using this machine, that is a transformer, everywhere you have seen. So before discussing about the transformer, let us know what is transformer. Okay, so its name says transformer means what? It transfers. So what quantity it transfers? It transfers electrical power, or you can say electrical energy, from one circuit to another circuit. That is called what? Transformer. That is why it is so named. Again. So what is the basic definition? Basic definition is what? It is a static device. So static device means what? It has no moving parts. Like you are in case of DC generator or motor, that is not a static device. It has some moving parts. So, so therefore it has no moving part. That means obviously it has higher efficiency in comparison to other electrical machine, because due to frictional, because it is static device means what? There is frictional loss is totally zero. So definition is what? What is transformer? It is a static device which transports electrical power from one circuit to another circuit. So let us draw the diagram of transformer. Or you can say how the energy is transferred from one circuit to another circuit. Let us discuss. So this is a schematic diagram of a transformer. So as I say, it transfers energy from one circuit to another circuit. Another thing, in case of transformer, there are two windings. One is primary winding, another is secondary. So now question is how one can know whether it is a primary winding or secondary winding. The definition is what? The winding to which we can give a supply, that is called primary winding, and secondary winding is what? From the power is drawn, or you can say where the load is connected. This side is load, this side is supply, or you can say source. So source side is primary winding and the load side is secondary winding. So this is regarding the winding. Another thing, according to the, then let us discuss the types of transformer. What are the types of transformer? So there are so many types, but according to the construction, there are basic two types. One is core type transformer, another is cell type transformer. And according to the voltage rating, there are two types. One is step-up transformer, another is step-down transformer. So in this way, there is a classification of transformer. Now next question is how the power is transferred from one circuit to another. You can say what is the working principle, how it works. Okay. Now see. So this is the primary side, this is the secondary side. You can say this is the source side, this is the load side. Now initially we give the supply V1, that is the source side. So due to this V1, there will be I1 current. Okay. Now see, this when this I1 current is flowing through this winding, so there will be one MMF will produce, that is N1 into I1. So what is N1? That is the number of turns. That is the number of turns at primary side, and there is a N2. N2 means what? Number of turns at secondary side. And I1 is the current at primary side, and I2 is the current at secondary. See how energy transfers. See. So due to V1, there is a I1, and when this I1 is current flowing through this primary side, there will be one MMF is flows. What is MMF? That is magnetomotive force. You can say simply it is a product of N1 and I1. That is a product of turn of this winding and the core. Itself says that it is a magnetomotive force. So due to this magnetomotive force, there is a phi. Phi will generate, or you can say flux. And this flux links the secondary winding. And this flux links the secondary winding, so that there will be what? Again there is a N2 and N2 will be produced. Because here there is a number of turns, N2 means what? Number of turns at secondary side. And due to this flux, the linkage of flux, there will be one current will produce, that is I2. And when this I2 current is flowing through this load, there will be G2 is. Now see, here power is initially the power is I1 G2, and at the load side there is a power is G2. And for the ideal transformer, this input power is equal to output power. That is V1 I1 is equal to V2. This is happens in ideal case. But in practically, due to winding, there may be some losses. But for ideal transformer, input power is equal to output power. So total the transformer action is based on the mutual induction principle. So in this way, the power is transferred from one side to another side. Thank you.